Hello class, welcome to the first lecture of stats. So today we're going to be talking about measures of central tendency. Sounds very fancy, but you'll see that it's not so bad and it's stuff you've probably thought about or at least heard of before. And so here is, oops, I guess I need a marker. So here is like sort of the major goal. Given a data set. So what is a data set, first of all? Well, just to keep it very basic, it's really just a list of numbers. So these numbers could represent lots of different things, but for now, you're just given like a whole bunch of numbers. What we want to do, we want to calculate something, some other number, but like it's the best number. We want to calculate a number that accurately, you could say it a few different ways, reflects the data, but I want to say it like this: it represents a, in quotes, typical, because that could mean a lot of different things, a typical data point. So for example, a data set could be like a list of heights or something. So you have a whole bunch of numbers that are heights, and what you want to do is you want to calculate from that list a number that represents a typical height in that list. Okay, and there's three very common ways to do this. There's three common numbers like that. So that's what we're going to go over today. So three commonly used such numbers. These are called the mean, the median. I don't know how to spell things. That's probably right. The mean, the median, and the mode are these three numbers. So they're just different ways to think about what a typical data point is. Three different ways to think about that. And you've probably calculated these before a long time ago. So we're going to go through some examples, but more importantly, we should think about how or why they actually do what they claim to do, which is represent a typical data point. Why does that actually happen when you do these three things? Okay, but first, just some calculation-y stuff. So let's find the mean. So we can see how this actually works of the following data set. So that means I need a list of numbers, and then I'm going to calculate the mean. So when I say find, I should really say calculate is another way to say it, because it's really something we're going to calculate. So first I need a list of data. So it's going to be sort of long. So I'm going to pause and magically appear the data. Okay, so here is this data set. So just a list of numbers. And I'm going to calculate the mean. So what I'm going to do is just give you the step-by-step instructions. Now, if you have access to a calculator or a computer, there are ways to just automate this entire process and just do it very quickly. But it is good to know the process behind it, at least do it a couple times. Okay, so the first step in calculating the mean is we just add up the numbers. So we got to do 82 plus 77 plus 90 plus 71 plus 62 plus 68 plus 74 plus 84 plus 94 plus 88. So at this point, you use a calculator. You definitely do not do this by hand, but when you do it, you should end up with 790. What you should understand is that by hand, you could do it. I could add these up. I'm not going to because that would be too much work. Okay, and then the next step to calculating the mean is you take that result and you divide specifically by the amount of number of data points, meaning how many numbers are there in this list. So you got to go back and count, and you'll see that there's 10 of them. So here I have to divide by 10 specifically. So all I do is I take 790 divided by 10. Again, this one I can do in my head, but oftentimes you'll need a calculator for this division. Okay, so 79. So that means that the mean is 79. The mean of that data set, this list of numbers, is 79. So the idea is that 79 is somehow supposed to represent in one number what these numbers typically look like. So as you can see, none of them are exactly 79, but the idea is that 79 is sort of nearby to most of them. Okay, let's just do smaller examples by hand just to practice. So find the mean of this 3, 4, 5, 6. So we're going to add 3 plus 4 plus 5 plus 6. And that time I don't need a calculator. I just need to cheat and use my notes that I previously did. That should be 18, right? Yes. And now I'm going to divide by 4 because there's only 4 numbers. 18 over 4, that's too hard. You need a calculator, 4.5. Okay. So once again, we should be thinking about how does this represent a typical number in this list of numbers? How is it representative of that list? And one thing you could say is, well, it's kind of next to all of them. They're all pretty close to 4.5. But we can look at a very similar example and see what sort of goes wrong when you calculate the mean and you ask the same question. So now let's find the mean of 3, 4, 5, and let's change 6 to 28. So we're going to add 3 plus 4 plus 5 plus 28. And we're probably going to need a calculator for that, but it turns out to be 40. Because I'm so wise, I chose a number that's divisible by 4 so that I could quickly do this next step of dividing to get 10. And so now if I look at 10, does that sort of look like any of these numbers? Not really. Now it's sort of far away from everything. So these are the types of questions that you should ask. So let me, in fact, ask them. So does 4.5 accurately represent a typical data point? Because that was the goal at the beginning, was to find a number that accurately represents a typical data point. And I would argue, yes, this does. It's because 4.5 is sort of near. And of course, near is, I guess it's sort of an opinion. I think it's nearby. Right now, it's just sort of an opinion. It's near the data points. So sort of nearby all of them, in fact. All 4 of these guys. But then if I ask that same question for the other set of data that I looked at, so does 10 sort of represent those? Then the answer is no. Same idea. So 10 is not really near, whatever that means, the data points or the numbers in the list, right? So 10 is not very close to any of these guys, 3, 4, 5, or 28. It's kind of far from all of them. So what this is telling us is that if all I do is change a single number, then suddenly the mean changes from being good to bad. And that's the big idea. So all we did was change a single number, or one data point, if you want to use fancy stats language, one data point. And what happened was the mean stopped being a good representation of the data. AKA it stopped being a good typical data point. So why did this happen is what we should think about next. What is it about this process that creates the mean that does this? That means that if I change one thing, then it all stops working. Okay, so it has to do with how the mean is central, to go back to the title of this lecture, central. So the way in which the mean is central is what's causing this. And this will be sort of thought about in the lecture problems in more detail, but it's good for you to think about right now. But for now, we're just going to move on to the median, because what the median is another way to think about how to find a number that's a representation of the data, and somehow it sort of works better. Okay, so this will be answered in the lecture problems. Now on to the median. All right, so same idea. If you just have a list of numbers or a data set, then what we want to do is calculate this other number or find it. So we find the median by doing this other process, which is a little less mathy, sort of seemingly. We just order everything. So we put the data in order. And then you literally just pick the middle one. So we'll see how to do that with the new example. But yeah, so the idea is if I just put everything in order, and then I pick the middle one, well, then that means it's like somehow close to all the other ones. So it should be a good representation of the data. Okay, but before thinking about big picture ideas, we can just do an example. So let's find the median of this data set. And I'm going to magically appear the data so you don't have to watch me write it all down. Okay, so here is the data. So what do we got to do? We got to put it in order. Well, because I'm not annoying, I already put it in order for you. It's really annoying if it's not in order. So let's just say it's already in order. And now I just pick the middle. So we can go ahead and do that by either counting or just sort of crossing things out. There's a couple ways to think about it, but let's do it like this. So cross these out. That's one way to do it. So I crossed 4 out on each side. So there's 4 over here. There's 4 over here. So this guy is right in the middle. So 217 is the median. Because it's in the middle. So however you want to figure out what the middle one is, do it however you want, and that's the answer. So you should notice that there could be an issue, because if it's not an odd number, then there's not really a middle. Notice here there's 9 data points, 9 numbers. And so the 5th one is in the middle for that reason. But what happens if you have an even number of evens? And it's a little more annoying. So let's use the first examples data set. So that data set is actually from a bunch of student scores. So I'm going to put them in order for you, but if you want to practice doing that, you can scroll up in your notes or rewind the video and try it. But I'm just going to put them in order here magically with the help of technology. Okay, so I've put them in order. And now I pick the middle, but then, whoops, there's two middles because there's an even number of numbers. So that's sort of one issue, but it's not that bad. We can figure out. So these two numbers are both in the middle because there's 4 on each side of them. They're both the 5th from either direction. So all we have to do is look at the middle of them. So since 77 and 82 are both the middle, we just find their middle. So what's halfway between 77 and 82? Well, the trick is you can just add them up and divide that by 2. And that'll give you the middle of the two numbers. Notice that that's actually the mean of two numbers. It's just a little side fact. Yeah. So that's going to be the median then. So this is what you do if there's an even number of numbers and there's two middles. You have to go between the two middles. So 79.5 is the median. Okay. Let's see. Let's think more instead of just calculating. Like we did with the mean. So let's do a little smaller example that we can just sort of think about what's happening. So find the median of these two different data sets. So 2, 3, 4, 6, and 8 versus 2, 3, 4, 6, and 55. So when I changed a single number for the mean changed completely. 4.5 became 10, if you remember. But now, in both cases, it's exactly the same. The median is just 4. So that's the middle number there. That's the middle number there because they're both already in the right order. So the median is 4 in both cases. And so now, even though I changed one number, the median is sort of a good typical representative of a typical data point. So that's the interesting part about the median. So let's sort of ask the same question. I don't know why I'm doing a color coordination thing, but there it is. So does 4 represent a typical data point? Well, now in both cases, yes. So 4 is mostly near everything in both cases. Of course, it's not near 55, but it is near the other ones. It's near the other data points. In both cases. So it's pretty good at being a representative of the data. So now let's think about why the median did not change so much, but the mean did. So that's the next big sort of question to ask, think about. So why does the median change? Sorry, I would word this a little bit differently. So why does an extreme change in one data point not impact the median, but does impact the mean. I don't know why I underlined mean. Unnecessary. Okay. Ah, my undo button is not working. Come on. Oh, wait, that's because I'm messing it up. Sorry. Go. Ah, this thing sucks. Okay, I hate technology. Ah, now everything's gone. Oh my gosh. Okay, here we go. All right, anyway, why does an extreme change in one data point not impact the median, but it does impact the mean? So the idea is that the median, this time I will underline it on purpose, does not take into account how far to the left or right a data point is. So it didn't matter that 55 was super far away and 8 was only a little bit far away. It just mattered that they were both to the right. It didn't matter how far they were. That's going to be the idea. So it doesn't matter. It doesn't take into account how far left right a data point is, only whether the data is to the left or right. It doesn't care about how far it is. The mean does take the distance into account. So the mean does take into account how far the data is. So, of course, it's going to be highly impacted by faraway things. By even a single faraway, a single big or far away data point. Meanwhile, the data point being big or far away won't change the median at all. Okay. So great, that's the difference between those two. Maybe you never thought about it, but you knew how to calculate it before. But it is good to think about these more interesting ideas about why and how things work, not just how to do stuff. Because a computer can do stuff, and computers are boring. But people can try to understand what's going on, and that's what you should try to do. Okay, so what else? So what this means, to sort of conclude the point of these two things, if you have a bunch of data, and there are data points that are far away, from the rest, then the median is probably a better representative. The median is probably a better representation of a typical data point. And the mean is probably not so useful. So you'll see this in real life a lot. People will use the wrong one on purpose to sort of make a point. And so this will be in the lecture problems, but just one thing to think about right now, and this will be in the lecture problems, is income. So what people will try to do is they'll say like, oh, the average is so high, because then they'll use the word average to sneakily not tell you whether they're using the mean or the median, but they're always using the mean because they're trying to trick you into thinking it's higher. So for income, you really should use the median But when people want to make it seem like the average income is high, they'll use the mean instead. And what's going on there is people that are super rich, their income will inflate the mean because it's very far away, and that's what happens with the mean, and it won't represent typical people. But you'll see that more on the lecture problems. Okay, that's a real life example. That's very good to think about. Let's see. So, but for the lecture, we mostly have to just sort of learn some stuff. So the problems are where you can see more real life examples and things. Okay, so next up is the mode. So a mode is a data point that appears the most often. So this is different than the mean and the median. So notice that in the previous examples, that the mean and the median don't actually have to even be one of the data points. So let's see if I can scroll up very quickly to see. So in that case it was, but up here, 79.5 was the median, but it's not even one of these numbers. So then you might justifiably ask, how could that represent the data if it's not even in the freaking list? Well, it's because it's just a different way of representing the data, being a typical data point. So the mode addresses that question. It says, fine, just tell me the number that shows up the most. And that's going to be another way to think about what a typical data point is. So first, we'll just see a little example of how to calculate it. So the mode of, so here's some data. This time I will just write it down. It won't magically appear at 2, 2, 4, 5, 6, 7, 7, 7, 9. So what's the mode here? Well, it's 7 because 7 appears the most, 3 times, which is the most times. So it's very quick to calculate the mode. And you could say, well, 7 seems like a good representative because 7 appears a bunch. So 7 seems very typical. Although what it doesn't do is it really doesn't represent sort of the fact that 2s are in here because they're kind of far away. So it's just a different way to think about what a typical data point is. And the mode is interesting because you could have multiple modes. So for example, here, the data 15, 15, 15, 27, 28. I can't read my writing. Oh, it's a 38, sorry. 38, and then the next one is a bunch of 49s. So this guy has two modes, 15 and 49, because they both appear the most, 3 times. And so in this case, this is a really good representation of the data because most of the data does look like either 15 or 49, whereas the median and the mean would actually be really bad here. They would not really represent anything. Because, well, I'm not going to calculate them for you, but you can try it. If you end up calculating, they'll be, I don't know, they'll be somewhere in between here. And that's kind of far away from everything. And you could sort of picture why. It's because you have a bunch of the same stuff to the left and a bunch of the same stuff to the right. So they sort of cancel to being in the middle when you do these mean or median things. And you end up with a number that doesn't really represent either side because it's sort of stuck in the middle. So now the mode is actually very good here, and the median are not. So now let's look at sort of the opposite situation when the mode is really bad. So your data doesn't have to just be whole numbers. You can have decimals and fractions and things, although I know fractions are scary, but that's okay. We'll learn to like them. So here are some decimals that are like less scary fractions, I guess. So here's just 4 data points. So what's the mode of this? Well, all 4 numbers are the mode, so it's kind of useless. Because if you just say every single number represents the data, well, then you're not condensing any information down. You're just saying the same data. It doesn't really help you picture the data. The point of picking just one number, or maybe 2, like in this situation, is that it represents all the data in a simpler way with just one number or 2 numbers. So here, you're just repeating all 4 numbers, so it's not very useful. Okay, so let's just sort of notice some facts about what's going on. Just to summarize, so the mode is useless. And examples like the one we just said. Doesn't tell you anything. Doesn't tell you any information. Doesn't summarize the data for you. It doesn't tell you what a typical number looks like in a faster way. But on the other hand, the 2 modes in the other example are both very good representations. But neither the mean or the median would be. In this class, we're mostly going to study the mean and a little bit of the median. So not much of the mode beyond this stuff, really. Okay, so then to summarize how the mode is central, well, it's not really central the same way that the other 2 are. So the mode is, even though it's in this section called measures of central tendency, it's not really central like the mean and the median. It just sort of fits in this section, so that's why. But the point is we don't use it often for that reason. So we don't use it often because most of the data we work with the idea is that the data will be clumped sort of together around the mean. And then what will happen that the mean and the median will be roughly the same. So there's just a little side note that we're not really going to touch on the mode much because it's not really measuring centralness. It is representing typicalness, but it's not really a middle-ish type thing, which is what we're really going for when we say the title of the section, measures of central tendency. We really want to figure out not just what represents a typical data point, but sort of what's in the middle of the data. Okay. It just so happens that being in the middle and being typical they sort of coincide very often, except in the case like where the mode was more useful above. Okay, so just some examples to think about. So in each scenario, let's think about which is the best. So which is the best measure? I can't spell. Best measure to use. So let's see. Income, I sort of touched on it earlier, but the median is the best thing to use. because it represents a typical income better. Most people will be around the same income, but there will be some people who have very, very high incomes, and that will push the mean away from the median much higher. And then the mean will no longer represent most of the typical incomes. So you might sort of think like, okay, it sounds like the median is always better because the median never changes. It doesn't really get affected by big data points far away. So that might have suggested to you like, oh, okay, that means the median is always the best. But there are situations in which you actually should think about the mean. And that's this situation, packing. So if you are sort of trying to pack stuff away, the mean is better. So why is that? Well, it's because now you actually do have to worry about not just whether stuff is sort of big or small in terms of size of the numbers, but you have to think about how much bigger, how much smaller it is, because you're trying to maybe put stuff in your garage or something. So the idea is that you need to account for very large items. So for example, I'll draw a little picture here. Okay, here's your storage unit. And you want to store all your stuff in there. So you want to know if it's going to fit. And so you have all these little cubes. I don't know. You have a bunch of cubes that you want to fit in there. But then you have this one massive cube. And you want to know, is it going to fit? Is all this stuff going to fit in your storage? And you say, well, I'll just average the size. So I'll take the mean size of these boxes. So of course, this is just a ridiculous picture, but you could say okay, the mean size is, I don't know, it's pretty big because there's one giant box here that will make the mean very big. And then you'll say, oh, it's not going to fit because on average, things are too big. But if you use the median, well, what's the median size of these boxes? Well, if I sort of put them in size order, and then I have this big one over here, well, the median size is this one. Oops. This one here, right? So then you say, oh, okay, well, that means on average, my boxes are this big. So I should be able to fit everything inside. But that's obviously not going to work because you're going to have this giant one that won't fit. So that's the idea. And when the median would actually be very bad. What else? Let's see. Let's do another example. The course grade. So a grade that you get in the class, pretty much it's always calculated with the mean. And so why is this? Well, it's because you can't just take the median of all your scores because that doesn't account for things that are more important that should count for more. So maybe you don't want this, but I want this as the instructor. So you want the bigger exams or the more important work to count for more. So what that means is if I have a bunch of assignments that are worth 1 point each, but I have this big test that's worth 100, then that should weigh into the average if I get a perfect score on that one. So let's say I got a 1, I got a 1, I got a 1 on these little baby assignments. and then I got a 50 on this test, well, then if I calculate my median, then I guess I'm between 1 and 1. So that's saying I got like 1 out of 1. So 100%. Perfect grade, A+. This would be what the median would be. But if I calculated the mean, I don't know, it would be somewhere. That would be I would probably be like around like 60 out of 100, which is like 60%. I'm not going to calculate it on the spot, but something like that. It's the idea. Okay. So I think that's all I wanted to talk about today. Let's see, anything else here? Sorry. Okay, yes, I do want to say a little bit more actually, sorry. All right, so just to summarize everything for today. So to summarize, the mean and median are numbers that represent a typical data point. In what way? By being sort of in the middle. Numbers which are, they're both in the center, but there's not just one center. They're both in the center in different ways. And that'll be more explored in the lecture problems. So what this means is that because they represent a typical data point by being near the center, that means that they can only do their job if your data is clumped into the center. So therefore the mean and median can only actually represent a typical data point if the data is actually near them, near the center. And since they are supposed to be the center, when I say near the center, I mean near them. We sort of saw this earlier, but one more final example that's more sort of extreme is the data like this. So if I have 1, 2, 3, 17, 18, and 19, then the mean and the median really don't tell you anything. They don't say a lot. They don't represent it. And that's because the numbers are not actually near the mean or the median. So to sort of think about what this means, we have to think about the word near that I keep using, and not just the mean and the median alone in a sort of a vacuum or a bubble. It's not enough to just think about that. So that's what we have to think about, and that's going to be what's for next time. So to better describe the data, we also have to think about what it means to be near the middle. So we also need to see how far the data is spread out from the middle. That's what we're going to learn to do next time. Right now, we're just sort of eyeballing it. If you calculate the mean or the median here, just very quickly on your own, let's see, 10, 20, 40, 60. What is it? Sorry, 20. I shouldn't have tried to do it on the spot. 20, 40, 60 over 6 is 10. So I keep sort of just eyeballing it, but the idea is like these numbers are not really near 10, so 10 doesn't really represent them. So I got to think about what does it actually mean to be near the middle? So that's what we're going to do next is we're going to figure out how to describe the spread of the data, the spreadness, how spread out the data is. And so the idea should be that if I calculate more spread, that should mean that the mean and the median are not useful. They don't really represent the data. And less spread should mean that they're useful, that they do represent the data very well. Okay, so that's going to be what we talk about next time. Next time we're talking about spread, how to figure out how spread out data is. Okay, so that's it for today. See you next time.